Hey everybody, so in this video we're talking about solving exponential equations. So anytime you're solving exponential equations, you always want your base of your exponent to be the same. When this occurs, you can take your exponents and set them equal to each other. So here I'm going to say this is 2x minus 3 equals negative 17, and now I'll just treat this like a two-step equation. I will add 3 to both sides. This is going to give me 2x equals negative 14. And then I can just divide by 2, and this is going to give me x equals negative 7. So the value of x here that would make these equal would be to plug in negative 7. Okay? Now, what happens if your bases are not the same? So let's think about this. It would probably be easier if I weren't dealing with a fraction here. Well, you can technically make this not a fraction. So I could turn this to, let's say, an integer. I could make this 2 and just give it an exponent of negative 1. Because we know that if I have, let's say, x to the negative 1, this is 1 over x. Whatever has the negative exponent moves. If it was in the numerator, it moves to the denominator. If it were negative in the denominator, it would move to the numerator. So here, because this 2 technically has a 1 that is positive, I could make it negative and move it from the denominator to the numerator. Now this is 2 to the negative 1 times x equals 32. Now it seems a lot easier to rewrite 32 to have a base of 2. So here, that would be 2 to the 5th power. And then here, I now have 2 to the negative x. So now I have rewritten this so that my bases are the same. That's the goal. That's what you're trying to get to. I always want the bases to be the same. So now that they are, I can take my exponents and set them equal to each other. So I have negative x equals 5. So x here is negative 5. And that would be the value that would make this equation true. Let's try another one. So here I have 4 raised to some power and 16 raised to some power. Okay, I can't rewrite 4 to have a base of 16. So I think, can I rewrite 16 to have a base of 4? Yes, I can, because 16 is 4 squared. So this is 4 raised to the x plus 4. This never changes. I'm going to rewrite 16 so that it is 4 squared. And then this is raised to the 4x minus 2. So see how I haven't changed the value of the equation. All I've done is rewrite the 16 so that it has a base of 4. Now, using my property of powers with exponents, this 2 is going to be distributed to the 4x and the negative 2. So now I have 4 raised to the x plus 4 equals 4 raised to the 8x minus 4. Now that my bases are the same, I can set my powers equal to each other. So here I have x plus 4 equals 8x minus 4, and I just have a multi-step equation here. So I'm going to take this x, bring it over here. So I would subtract, making that 7x. I'll take this 4 and add it over here, giving us 8. And to get x by itself, we're going to divide by 7. So the answer is 8 over 7 here. And this would be the value of x that would make this equation true. Okay, let's take a look at a few more examples. So here in these equations, none of my bases are the same. So what I will have to do is rewrite the bases. Here I have 81, and here I have 27. So I need a common base between these two numbers. Okay? Here, that is going to be 3. So 3 raised to what power would give me 81? And that is going to be 4. So here I have 3 to the 4th, that is 81, and here I'll keep that raised to a power of n, equals, and I'm going to rewrite 27. 27 is 3 cubed. Now I need to multiply here, so I have 3 to the 4n equals 3 cubed. Now my bases are the same, and I can set my powers equal to each other. So I have 4n equals 3. So now we know that n is 3 over 4. Okay? With this example here in the middle, we need to isolate the exponent itself because we're solving for x. So this 4 is cumbersome. It needs to go. Well, this is 4 times 2 raised to the x. So if they are multiplying, I am going to divide. So I would divide each side by 4. This gives me 2 to the x equals 1024 divided by 4. And this is 256. Now, I cannot rewrite the number 2 to have a base of 256, but can I rewrite the number 256 to have a common base of 2? And I believe that I can, and that would be 2 to the 8th power. So here I have 2 to the x equals 2 to the 8th power. So now I can set my powers equal, and x here is 8. Again, over here, we want to isolate the exponent. So I have a few things to do first. I will subtract the 11. This gives me 6 times 2 to the x equals 395 minus 11 is going to be 384. I still want the 2 to the x isolated, so I will divide both sides by 6. Here I have 2 to the x equals 384 divided by 6 is going to give me 64. And again, I can't rewrite 2 to have a base of 64, so I will try to rewrite 64 to have a base of 2. So 2 to the x equals 2 raised to the 6th power. So it looks as though x is going to be 6. And that's pretty much it. That's the gist of solving exponential equations. All you're trying to do is isolate your base and your exponent, and you're trying to get common bases on both sides. Once that's the case, you set your powers equal, and it's as simple as solving equations from there. All right, I hope that this video helped. If you have any questions, please leave them in the comments, and we'll see you all in the next video.